To illustrate the paired t-test, I'm going to use the data in the file called velocity of muzzle rounds. This one is a paired situation. We are comparing two devices to measure the velocity of a muzzle round. And we have 12 rounds, so a bullet presumably is shot out of a gun of some sort, and it's measured by device A, and at the same time it's measured by device B. A second round is shot out of the gun, and again it's measured by device A and device B at the same time. So we have 12 rounds, each one of those 12 rounds being measured by two different measuring devices. So that's what makes this a paired situation. Now, we are asked in the question to determine whether there is any difference in the velocity of the rounds, and I know the question doesn't specifically say that, but we've got 12 numbers for each group. Generally, what that means is we want to compare their average. So what's the average velocity from device A versus the average velocity from device B? Is there any difference? On the next slide, I've set up my null hypothesis. And note the way I've written this. I've got the average difference is equal to 0. I didn't set this up as the average of device A minus the average of device B equals 0, because when we do this test, it is different from the two-sample t-test in that the calculations really are only done on the differences. And we'll illustrate that now when we go into Minitab. So getting Minitab opened up, I've got my data here. I've got my 12 rounds if I scroll down, and my measurements from device A and device B are in two separate columns. Note that in my file, I do not have a column here in which I have found the differences. I don't necessarily have to do that because Minitab will do that for me. So in doing the paired t-test, we go to the Stat tab, Basic Statistics, and we know these data are paired based on the muzzle round, each muzzle round being measured by two different devices at the same time. Okay, we have each sample is in its own column, and the only choices I have here is to use individual data sets or have summarized data, which I don't have. And in the notes, I simply set this up as device A minus device B. I could go B minus A. It doesn't really matter in this case. I simply want to know, is there a difference or is there not a difference? I go to Options. I think we were asked to make our decisions at a 0.01 level of significance, which means if I want to look at a confidence interval, I need to change the confidence level to 99. My hypothesized difference is that there is no difference. I want to know whether there is no difference or whether there is a difference, not equal to 0, but I don't know, or the question doesn't ask me whether that difference is positive or negative. Click OK to that, and you should always go to the Graph tab, and you should have a look at the box plot of the differences. Click OK. All right, I'm just going to move that box plot out of the way here for a second. Now, I get some, first of all, summary information on each of the two devices. So there's the average velocity from device A and that from device B. There's not very much of a difference between these two numbers. What is the actual average difference between those two numbers? It's 0.117. So the question is whether or not 0.117 is a big enough difference to say that there is a true difference in these two measuring devices. Okay, now the t-test is carried out on that bit of data right there. So when you calculate your t-value, which turns out to be 0.85, the stats that are shown there in your notes tell you to take the average difference of your sample, here it is, minus 0 in our case, divided by the standard deviation of the differences, here it is, divided by the square root of 12, and that 0.475 divided by square root of 12, by the way, remember, is the standard error of the mean. So really, my statistic really is simply 0.117 divided by 0.137. That gets me a t-statistic of 0.85. It's a two-tailed test. Always check this. So I did no difference versus that there is a difference, but I don't know or don't care whether it's positive or negative. And I look at my p-value. So the question then becomes, is your p-value less than alpha? We were told in the problem to use an alpha of 0.01. Is this number smaller than 0.01? Clearly not. That means I failed to reject this statement. What does this statement really mean? It really means there's no significant difference between these two measuring devices. Now, whenever you do a paired t-test, one of the absolute assumptions you have to check is whether the differences themselves are normally distributed. Minitab automatically gives you this box plot. When I look at this box plot, it looks fairly positively skewed, really. The right-hand side of my box is a lot longer than the left-hand side, and my right whisker is a lot longer than the left whisker. So we really need to check whether or not these differences have a normal distribution. Now, unfortunately, when Minitab runs this test, it doesn't actually show you the differences. So if you have to do, let's say, a Ryan-Joyner test to see whether those differences follow a normal distribution, you're going to have to get Minitab to calculate the differences for you. I'm setting up a column here in column C4. I'm calling it diff for differences, whatever. And what I want the program to do is to take the measurement from device A and subtract the measurement from device B, and do that for each of my 12 pairs. So to do that, I'm going to use the Calc tab and this calculator function that we have seen before. Now, first of all, it wants to know where are we going to store the result or the answers. Once we tell Minitab to do something, it wants to know where do you want me to put the result. And I've already set up a column called difference, so I can just select that. Now, if you hadn't already named your column, you could type in any empty column up here. You could just say C4, C5, whatever. Now, what is my expression? I simply want it to take the number that's in device A minus, and I'm using my keyboard, or you could use the minus here on this little keypad, minus the number in device B. Click OK, and if I scroll down here, here's all my differences. So now that I have the differences, I could go and run a normality check. Going to Stat, Basic Statistics, Normality Test. I want to test simply the differences. That's all I need to check. And because I got a small number of differences, I typically will go with Ryan-Joyner. Click OK. Now, when I look at this, there's a little bit of an issue here. The points don't exactly follow a straight line. The p-value is 0.085, which is greater than 0.05, which tells me that my data are not normal, but because the p-value doesn't exceed 0.1, they're not exactly normal either. So when I'm in a situation where that p-value falls between 0.05 and 0.1, I call this borderline normal. So, you know, our data don't exactly meet the normality assumption. They're not bad, they're approximate, and that's really all you need anyway, is that they are approximately normal. You know, when I look at the means of the two groups right here, the 0.4, the numbers are pretty much the same. They differ by 0.117. Do I expect there to be a big difference between these two groups? Not really. Those numbers are pretty similar. All right, the other thing too, by the way, is let's have a look at what the confidence interval tells us. So it says we're 99% confident that the true difference, the true average difference between these two measuring devices could be as small as a negative 0.309, or it could be as big as 0.542. So because one end of this interval is negative and the other is positive, 0 falls in this interval. What does that really tell me? It tells me there's no significant difference between these two groups.